Hello students, let us see this problem from TIFR-2015 from section A, question number 25. So in the question you have been given a circuit, that is a voltage divider bias given to an NPN transistor, and they are asking the minimum value of BC. Now, why they are asking minimum value BC? So in general, in the question, the resistance value are given which are fixed. Okay. Now in this particular question, the new thing is that these values are not fixed. They have some tolerance of 5%. So with this 5% tolerant, okay, what is the possible minimum value of this VC? We need to calculate. Now, if I want to look at the VC value minimum, then this is the VC is VCC minus ICRC drop here. And now if this has to be minimum, we have to maximize this one. ICRC should be maximum. And now ICRC can be maximum only when I take the maximum value of RC. So RC value is given 150 kilo ohm. If I take 5% error also, so the maximum value of RC is this one. So I take the maximum value of RC. Similarly, I also have to maximize IC. And in this question, since beta value is not given, we can take IC equal to IE, and we can use approximation method to calculate the IE. So then, if IC has to maximum, IE also has to be maximum. And now, if IE has to be maximum, we have to take this is the minimum value. So I will take this RE value as minimum value. Okay, subtracting 5% error. Similarly, now if this IE has to be maximum, here VE also has to be maximum because IE is VE minus RE. And now to VE has to maximum, VB should be maximum. And now if I want VB to maximum, then this drop should be maximum here. For that, I have to take the maximum value of this resistance R2. If I say this is R1, this is R2. So this R2 also have to take the maximum value. And out of this 10 volt here, as possible, as less voltage should drop here and maximum voltage should drop here. So the minimum value here, so I will take the minimum value of this 330 kilo ohm, that is 313.5 kilo ohm. So now these are my values, okay? Because I want minimum VC here, so I will take the these values for my calculation of VC. Okay, so once I understand this concept, now we can do the calculations. So first of all, I need to calculate VB, assuming IB is 0 because beta value is not given, so we have to use the approximation method. So let us calculate now VB. So VB value will be what? VB value will be, if I take this is the minimum value and this is the maximum value, so this will come out 105 kilo ohm divided by sum of this one, this is 330 and this is 105, 418.5 kilo ohm into total voltage is 10 volt. So this will give me VB value equals to 2.508 volt. Now this VB is given 0.7, so V will be your VB minus 2.508 volt. This is, so I will get the VE value 1.808 volt. Now once I know this value, I will take the minimum value so that I can maximize. So my IE value will be 1.808 and minimum value of 10 kilo ohm, 5% less, that is 48.5 kilo ohm. And if I solve this one, this gives me the IE value 0.0373 milliampere, ampere, and this IE I will take equal to IC. Okay, now I know the IC, so I can find VC. So my VC will be what? VC will be VCC. This is VCC minus ICRC, that is 10 minus 0.0373 into 10 raised to power minus 3. RC value, I will take the maximum because I have maximum drop here, it will be minimum. So the maximum will be 157.5 kilo ohm. Okay, and if I solve this one, this comes out 10 minus 5.8 0.77, that is 4.12 volt. Okay, this is the minimum value. So now if I calculate, see the options, the B given as a 4.1 volts, and this is the correct answer for this question. Okay, if you calculate this, if you take it as a fixed value, then the receipt becomes somewhat different. Okay, but there in the question we have to calculate minimum value. So accordingly, for the minimum, this should be maximum, this should be minimum, this should be maximum, this should be minimum. So then only the answer will come. Okay, hope you understand the question. Thank you very much.